gonna find the flux integral with respect to this vector field in these borders. This will be the solution if you want to try it for yourself. We're gonna use Gauss theorem, so we're gonna find the triple integral of the divergence of u, and we're gonna subtract the bottom or upper surface depending on how this figure looks. So let's begin to find the divergence of u. So we're gonna find the partial derivatives with respect to the vector field of each component. So we're gonna have divergence of u. It's gonna be partial of x squared minus y with respect to x. So that's 2x plus the partial derivative of yc with respect to y, which is c, and the partial derivative of x squared with respect to c is 0. So we just have 2x plus c. And let's go ahead and find the triple integral of 2x plus c. So first of all, we have to look at our figure. How does that look? So the figure c equals x squared plus y squared is a cone. So it should look something like this. So, and down here we have our the xy plane. This will be the c plane with the normal pointing up, and the xy plane is going to be down here. So if you climb along the c-axis and look down, you will only see the circle. So it's basically cylindrical coordinates, which means that we have to go along the c first. So let's do that. So the triple integral to x plus c with respect to c is going to be double integral of 2xc plus c squared over 2. The borders of c are these. So it's a bit tricky. You have to think maximum value of c is 2. So let's put in our borders. 2, c. And then what's the bottom border? It's not 0, because, well, c also is these circles running down here, all the way down to when the xy plane will be 0. So it's actually x squared plus y squared. That will be the bottom border. So let's put in our borders. If you know cylindrical coordinates, you know that x squared plus y squared is r squared. So this is actually r squared, the bottom border. And when you change this, you also have to change all the x's to cylindrical coordinates, so they match. So we end up with double integral 2xc, we put in 2, so we're going to have 4 r cosine theta. X is r cosine theta. And then we have plus 2 squared, 4 over 2, that's 2. And I'm going to subtract. So we have r squared now, the bottom border. I'm going to put that in for the c. So x is still r cosine theta. So we're going to have 2 r from the x, and then r squared here. So it's going to be 2r to the third, and then cosine theta, plus r squared for c. So we're going to have r to the fourth over 2. And then we have to put parentheses here. So that sign is going to change to a negative sign. Alright, and we also cannot forget the Jacobians. We have r dr d theta of this entire expression. Alright, so let's see here. If you look at this circle, we can see that r actually runs between 0 to 2 pi entire way. So that actually means that this part and this part is going to become 0. Because if you only look at the cosine theta part, so when you take the integral of cosine theta, it becomes sine theta. And sine theta between 2 pi and 0 is 0. So this is 0 and this is 0, which means that you only have the double integral of 2, and this negative sign change this positive sign to negative, so it's going to be negative r to the 4th over 2 with the r outside still. So r dr d theta. So we actually now took the integral of this with respect to theta. So because of that, let's just rewrite this, because what we actually have is the integral of 2 minus r to the 5th over 2 if we throw in the r. So we have 2r minus r to the 5th over 2, and we have dr. So we took the integral of this with respect to theta, and we got 2 pi left. So this integral with respect to r is 2 pi, and we have 2r with respect to r. The integral will be 2r squared over 2 minus r to the 6 over 12, and the borders for r we have here. So if 2 equals r squared, then the square root of 2 will be r. So we have square root of 2 and 0. So the square root of 2 squared is 2 times 2, that's 4 over 2. So 2. So we have 2 pi times 2, and we're going to subtract. So we have 2 squared to the 6th power. That is the same thing as 2 to the 3rd power. That's 8. 8 over 12. If you simplify that, that's 2 over 3. So we're going to have 2 over 3. If you make 2 to a fraction like this, we will have 6 over 3 minus 2 over 3. That's 4 over 3. So we have 2 pi times 4 over 3, which is the same thing as 8 pi over 3. We found the divergence. It became 8 pi over 3, since we got 2 pi times 4 over 3, and that's 8 pi over 3. So the divergence of u, the triple integral of that, was 8 pi over 3. So we got this component, and we just have to find this component. So first we have to see what is the normal of this cone. The normal of this cone is right here. So it's just pointing straight up along the z-axis. So the normal is going to be 0, 0, 1. So if you take 0, 0, 1 times u, you can see here that 0 times x squared minus y is 0. 0 times y is 0, and 1 times x squared is x squared. So we're going to have the double integral of x squared. And since it's a circle, we have to change the coordinates, and we get double integral of r squared cosine squared theta times r dr d theta, just like before. So this is the same thing as the double integral of r to the third cosine squared theta. So if we take the integral of r to the third, we get r to the fourth over 4, and we have cosine squared theta, and the borders for r, just like before, is the square root of 2 and 0, and the borders for theta is 2 pi and 0. So the square root of 2 to the fourth power is the same thing as 2 to the second power, and that's 4. So 4 over 4 is 1. So we just have the integral between 2 pi 0 of cosine squared theta. So this is slightly tricky, but we can use some trigonometric identities to simplify the expression. And the simplest one is just to say that you have the integral between 2 pi and 0 of 1 plus cosine 2 theta over 2. That is the simplest one we can use here. So if you factor out the 2, you will get integral and 1/2 outside, and we have 1 plus cosine 2 theta. So let's do the integral. We have 1/2, and we have theta plus the integral of cosine 2 theta is sine 2 theta over 2. And the borders were 2 pi and 0. So this component is 0, sine of 4 theta is 0, and sine of 0 is 0. So we just have this, and we have 1/2 in front. So we have 1/2 times 2 theta, which is, 2 pi, which is pi. Alright, and since we had 8 pi over 3 from divergence, we have 8 pi over 3 minus pi. And if you change that into a fraction, you get 3 pi over 3. And when you have 8 pi over 3 minus 3 pi over 3, which is 5 pi over 3, which is the correct answer.